One, my name is Sandeep, and today we are here to learn from James Dales about geospatial analytics in Power BI. Little bit about myself. So we have been assembling here at the Power BI Vancouver Fabric and Power BI user group. And I say this is our eighth session so far. I run it with my friend Parvinder. He is in Canada, Vancouver. I am in Portland, US, but we are in the same time zone. So it's why decided to get together and start this user group. I am a Microsoft Fabric MVP, and we've been very active in the community, Power BI community, Fabric community. I am on the socials, but I've been trying to cut down on my socials. So I used to say I'm there a lot, but not anymore. But feel free to connect with me. I check it at least once a day. And today we have James Dales. I've been following James for a long time, never had really an opportunity to interact with him or meet with him in person, but looking forward to that, maybe in sequel bits, who knows. But James is a Microsoft Data Platform MVP. And I know, James, you started your company very recently, so would love to learn more about that, but congratulations on that too.
Yeah, thank you. Yeah.
And before we start again, this event is recorded and the link will be shared on the meetup. Perv is out today, but he is very diligent about it. Usually he uploads the recording right away in 48 hours, but maybe look forward to it early next week. And please keep yourself muted during the presentation. If you have any questions, please use the chat. Add a prefix Q so we know we have questions. And then if James takes a break during his presentation, or if there is a point where James would like to answer the question, we'll go ahead and do that. Otherwise, we'll just keep going and then wait till the end to get all the answers. Future presentation is by our friend Fernando, but we'll talk about that after a bit here. So James, all yours.
Awesome. Right, let me share my screen. Give me a thumbs up when you can see that, and I'll make a start. Awesome. So, yeah, well, we think we've pretty much done introductions. But yeah, hi everyone. I'm James Dales, and as Sandeep mentioned, having spent the last 25 years or so in data and AI consulting, as of April last year, I started a new company that is focused entirely on geospatial analytics on the Microsoft platform. Initially focused on the visualization side, but throughout this year, that's going to broaden out to a lot of the more back-end processing side and also around the analytical side as well. So lots of exciting things to come this year, but I don't want to give too many spoilers. We'll have to wait and see what happens throughout the year. Also co-leader of the London Fabric user group, along with my friend Prathi. And I see we've got Anthony on the call as well, who presented last night. So great to see you again today. But yeah, contributed to a couple of the visuals in Power BI itself back before COVID, but probably best known for my work in mapping and the icon map visuals, which I'll talk a bit more about in a little bit. So what am I going to cover in this session? Well, I'm going to keep it super simple. I'm going to start by talking about what we can do in Power BI out of the box, what's available now, and then I'll talk in probably more depth about what the options are for when we want to be able to do more. So today, if you open up Power BI Desktop and you want to add a map, you actually have 5 options for creating that map. We've got 5 map visuals. We've got map, filled map, shape map, Azure Maps, and ArcGIS map. But things are about to change. So Power BI has been around now for nearly 10 years. So have these first 2 visuals. So the map visual and filled map visual were around right at the beginning of Power BI. And a lot's changed in that 10 years, particularly in browser technology and in the geospatial world. So going back to the beginning of Power BI had to support Internet Explorer, if you can remember that far back. It was the most popular browser. People weren't really using Chrome, and Edge didn't even exist back then. So the original visuals were part really of a previous generation of web technology, and they used the Big Maps API that had to work back in the Internet Explorer days. But that technology isn't used so much anymore, and in fact the Bing APIs have been deprecated by Microsoft, and in just a couple of months they're going to turn them off. So I'm assuming that towards the summer the map and filled map will no longer be available in Power BI, and everybody's reports will be migrated to Azure Maps. Now that's a bit of an assumption, but at some point those maps will cease to exist. So I would highly recommend not creating any more Power BI reports using the map and filled map visual. Then we've also got Shape Map. Shape Map has been a bit of a running joke in Power BI. If you go into the options in Power BI desktop and preview features, it's there at the top of the list, and it's been there at the top of the list now for 9 years. It's the longest preview feature, and it will never come out of preview. So Microsoft has stated that the intention is that those 3 initial visuals on that list will be replaced by the Azure Maps visual. So that leaves us with these 2. We've got Azure Maps, which is the next generation of mapping from Microsoft, and then we've got the ArcGIS Maps visual, which is interesting in that it's a visual not actually created by Microsoft, even though it's shipped out of the box in Power BI. It's actually created by the GIS market leader, a company called Esri. But for all intents and purposes, it's a custom visual that Microsoft have agreed to ship along with Power BI. So that's it, that's my last slide. Let's jump out of PowerPoint, and I'm going to spend the rest of the session in Power BI. And I'm going to start in the UK, and then we'll move over the Atlantic and into Canada. So we're going to build some maps. I'm going to start with the Azure Maps visual. To do this, we need to obviously have some data. So I'm just going to use some open data. It's my favorite data set. If you've seen me present before, you'll have seen this data set. I've used it since the very first dashboards in a day, again, back in the beginning of Power BI. So in this data set, it's pretty straightforward. Each row represents an individual crime that happened in 1 month in England in March 2023. Doesn't really matter when it happened, just that each row represents a crime. And then we've got some geospatial data in here. We've got the longitude and latitude representing where that crime occurred. Then we've got a what's called the LSOA code. This is a census region in the UK. It's relatively granular, but it's bigger than a zip code, but much smaller than, say, like a state or local authority area. Then we've got the sort of type of crime that occurred, some other columns that I'm not going to go into, and then a couple that I've added myself. We've got the crime count, which is hard coded just with the number 1 all the way down for every single row, just because I'm too lazy and too scared, to be frank, to write DAX in a session. So this just means I can just aggregate up all these ones, and it will tell me how many crimes occurred of a particular type or in a particular place. And then I've got this other field called lang.combined, combined, and this is just a text field with the longitude and latitude combined into a single string. And you'll see why this is useful in a minute. But this gives us a unique identifier that represents where that crime occurred in a single field. There's nothing else in this data set that denotes an individual location in the single field. So this just gives us that capability. And then I've got another table in here as well, which I'm not going to walk through column by column, but it's just a geographic lookup from that census area up through local authority area into regions. So let's get started. I'm going to add the Azure Maps visual onto my report canvas. And I am going to drag on our location data. Now, as we've seen, we've got longitude and latitude. So let's start there. So I'll just drag those two fields on. And very quickly, actually, we get circles appearing on the map. And we might assume that we have a circle now on the map for all of those crimes that occurred back in March 23. But we need to be careful. If we look up here in the top right-hand corner, we get this little eye icon, and it says that it's showing significant data points. If we click on that, it gives us a bit more information. In Power BI, there's a limit as to how much data we can send to individual visuals, and different visuals have different limits. The old Bing Maps visual, for example, could only plot 3,500 rows of data on the map at a time. The Azure Map visual is much better. It supports 30,000 rows of data at a time. But the fact that we've got this little eye symbol here, it's basically telling us that we're trying to put more than 30,000 rows into this visual. And actually what it's doing is it's saying it's prioritizing the data points that aren't hidden by neighboring points. So if we want to try and understand where our clusters of crime are on this map, Power BI is intentionally removing some of those clusters so that the map's more covered in circles. So we need to be really careful. So let's have a look actually how much data we're trying to put on at a time. So I've just dragged on a quick card visual and then drag in my field and just do a count. We've actually got 436,000 rows of data in this data set. So basically, we've got 30,000 shown on the map and we've thrown away more than 400,000 data points. So we're potentially losing a lot of the information, insight that we're trying to gather from the map. So what can we do about it? Well, map visuals are no different to any other visual. There's some common strategies that we use when we've got too much data to put on an individual visual. And the first of those strategies is to filter it. So if I add on a region slicer, and let's just slice and just have a look at London, then we get circles just showing London, but we can see that we've still got 85,000 rows of data. So there's still more than half of it that we're not able to visualize. However, if I change my count of rows to a count distinct, bearing in mind we're using that unique location field that I created, whilst we've got 85,000 rows of data, we've actually only got just over 30,000 unique locations. And because we're only putting circles in individual locations, if we put a circle on top of each other, we're not going to see it. What we can do is, instead of sending 85,000 rows, we can send 30,000 unique locations. And we can do that by dragging in our unique location ID into the location field. And we'll get an error initially because we need to change the aggregation type on our existing longitude and latitude fields to average. And then what it will do is it will average for each unique longitude and latitude, the longitude and latitude field. So actually, for each row in here, each unique location will get one longitude and latitude record, but it's just averaging, taking the average of one row. So it doesn't change any data, even though we've got the averages in there. So now we've got 30,000 locations on the map, and you can see that it started drawing here on the right-hand side, moving across to the left, and we've got this pretty much vertical line here where it's hit our 30,000 row limit. But drawing 30,000 rows on the map and only throwing away 660 is a better place to be than where we started, throwing away 400,000 rows. But there's still more we can do. If we're not too worried now about losing some of that accuracy on the 660 rows, what we can do is drag in crime count into our size field, and then that triggers the visual to go back to using that initial algorithm where it samples all of that data. But if it's sampling 30,600 rows to give us a better picture rather than sampling 400,000 rows, we're probably still getting a pretty accurate picture of what that data looks like. But interestingly, you can see now by adding those extra 660 rows in, we've got quite a big circle over here that we were missing, which is actually over Heathrow Airport, which is responsible for a large amount of crime in specific spots in London. But it's a pretty horrible visualization, right? We're not actually able to use this to do much analysis. And there's different options that we've got in Azure Maps. We can start to cluster, which I'm really not a big fan of for this kind of analysis, at least with the Azure Maps visual, because it well, we can improve the formatting by increasing the sizes of these, but every single circle is the same size, and the colors, unless they've added it, don't support conditional formatting. So it's really hard to tell the difference between this circle here, which contains 6 locations, and this circle here, which contains 3,800 locations. So it's yeah, it's not easy to see what's going on. And it's also based on the number of locations, not the number of crimes. So if you had one circle behind here responsible for 10,000 crimes, this would still only show 3,800. So it's a little bit misleading. A heat map would do a better job, and we can tweak the values in here to get something that's visible and tells us a little bit more at different zoom levels. But I still prefer the circles when we get into the detail. So to be able to create a map where we're not throwing any data away and we can still get to the detail, there's still more that we can do. So we've got our geographic hierarchy over here on the right-hand side. What I'm going to do is drag in the fields higher up that hierarchy. And then because we're averaging the longitudes and latitudes, we will get effectively the center point for where all of the crimes occurred within each of those levels. So at this point, I'm showing the local authorities in London, one row for each, or one circle for each, and then I can drill down, in this case into Westminster, and then into Soho, to see that at that granular level, precisely where those crimes are occurring. And because we're doing drill down, even those 660 rows are being represented because we're only sending a subset of data to the visual at a time. So I like this. It works quite nicely at the detailed level. But back out here at local authority level, whilst we can see that this circle here for Westminster is responsible for the most amount of crime, we can't actually tell where Westminster is really on this map. What it would be nice to have is the boundary of Westminster. So, what options have we got for drawing boundaries on the map? Well, let's remove almost all of our fields and explore the functionality that we originally had in the field map, which is now in Azure Maps. So if I turn field map on, now initially we'll not get anything because I'm using a local authority code field, but if I use the name instead, Azure Maps will now try to use the names that I've passed here. So we've got all of the London local authorities, and I would kind of like the different local authorities in London displayed based on their areas. But instead, we've got London, all of those local authorities just shown as one area, and Merton shown as an area down here. And there are things that we can do. We can try and give Power BI a bit of a hint to say that my local authorities are, well, we don't have a local authority field to pick from, but probably the closest on here is a state or province. So if I choose a data category for that, then it's now doing a better job. I've got most, but not all of the London local authority shown. We're actually missing Westminster and the City of London. And if I zoom out and look at the whole of England, well, we seem to have matched one in New Zealand, but ignoring that for a minute and coming back into the UK, I'm not quite, oh, and we seem to have the Netherlands as well. But also, I'm not quite sure what these shapes are. I don't think there's a region in the UK which includes all of this. I mean, that's multiple local authorities, even with the very latest boundaries. It's at least 2 or 3. So, to be frank, it's probably fine at country level, and it's probably fine for US zip codes. It's actually fine for Canadian provinces and territories as well, with some caveats, but it's not really usable at all for UK geography. But the good news is, with the recent additions to Azure Maps, the story doesn't end there. We can now bring in a reference layer, to use Azure Maps' terminology. So we're going to upload a file containing those local authority boundaries that I've downloaded from the Office for National Statistics in the UK. So if I pull that in, we can now see all of those local authority boundaries, the correct ones. So you can see up here, there are many, not one large one across the north of England. And if I choose custom colors here on the unmapped options, we'll see that I've got data for England. So England's in blue, and then Scotland, Northern Ireland, and Wales are in black because I don't have any data that relates to those areas. So I'm going to choose to remove those. And then I can now, this is relatively new functionality, choose to conditionally format those local authority areas based on the number of crimes. And then let's reduce the border down, change it to black. And we get a pretty good choropleth map of those different local authority areas. And it's nearly usable. It's a shame because there's a couple of key things missing. One that's perhaps not quite as important, but there's little things that don't quite work. So for example, if I try to use the lasso control to highlight particular local authority areas, unfortunately, it doesn't work for the shapes. You still have to click on individual ones. Ooh, I'm in a bit of a mess there. Let's turn that off again. But more importantly, if I now want, oh, it's going to crash. Please don't crash. You also get quite a lot of crashes. Might give up on this, but you can see it's not quite there. The other thing I was going to show was, more importantly, you can't slice the data. You can't use a slicer and then the map zoom to those areas. So I will try it. Yeah, I'll give up on that. Even though it's crashed, what I was going to show is that as I'm here looking down in the southeast, if I now filter to look at the north of England, the map doesn't automatically zoom to the areas in the north. I'd have to start dragging the map around and explore and try and find the areas that are still in context. It's not so bad for the UK, which is a relatively small country. But if I start doing that in Canada, if I'm over in Vancouver, zoomed right up into the city, and then, you know, I slice to an area in Newfoundland, I stand very little chance of trying to find those areas. So I'm going to have to close Power BI down and open it up again. So just bear with me. See if I manage to pick the right Power BI, but I bet inevitably I'll pick the one that I want to use in a minute. Oh no, there we go. Good. So I'm just going to open up that file again. Right. I think we're back where we were. So the Azure Maps visual has come on massively. It's leaps and bounds beyond where it was this time a year ago. And I think with a few tweaks and a few bug fixes, it will be able to generate a really good choropleth map based on those custom boundaries, and it'll be good. In the meantime, we have got, of course, the ArcGIS map. But the ArcGIS map, whilst it supports some inbuilt boundaries, if you want to import your own boundaries, first of all, you either need to make those geographies public, or you need an ArcGIS subscription. But even with an ArcGIS subscription, once you've uploaded your own bespoke boundaries and bring them into Power BI, you can filter your report based on those boundaries, but you can't conditionally format them based on data in your Power BI dataset. So I couldn't create that choropleth map using my crime data with the ArcGIS visual. So, of course, the good news with Power BI is that when we're not able to achieve the output that we want with the out-of-the-box visuals, we've got this amazing custom visuals marketplace where we can extend the core functionality that comes with Power BI with third-party visuals. And we've got some great choices for maps now. There's more and more appearing all of the time. Now, up until, well, at this point last year, the go-to choice was probably either my old visual that I created quite a few years ago now, Icon Map, or the Mapbox visual. But things change. So Mapbox visual, unfortunately, isn't supported by Mapbox anymore. You can see it's being maintained by a third-party company when they have time. And if you read the comments, unfortunately, the reliability of that is perhaps not what it was, partly because it's using some really old custom visuals APIs now that probably could do with being updated. And then icon map. So icon map is a visual that I started developing actually more than 8 years ago now as a side project outside of work. And its popularity grew over time to the extent that this time last year I was getting sometimes 10 or 15 emails every single day, which for me to be able to keep on top of and be able to reply to people, I could easily spend the whole day trying to help people on top of a full-time consulting job. And it got to the stage that I was only able to answer a small amount of the emails that I was getting, and I hadn't managed to add any new features for well over a year into the visual, just trying to keep up with the support. So I decided that that wasn't really fair on anybody. The old icon map kind of became unsustainable as a free community visual. So I set up Tcantis, launched it in April last year, and in the last week of June, we released the first version of Icon Map Pro. So Tcantis is now my full-time job, our entire focus. It's not just me, there's a few of us now, with the aim of ongoing development of Icon Map Pro, supporting it properly, but also building a suite of other products around it, but all focused on geospatial processing within Microsoft Fabric and Power BI. So I'm going to take you through, it'll have to be a small subset of the capabilities of Icon Map Pro. And we will start with this data set, I think. Now I'm going to be brave and use my latest dev build, which is still being tested, but we hope to get this out in the next 2 or 3 weeks into AppSource, because there's some big fundamental new features in here that we'll get to in a minute. But I'm going to start with the same use case that we've been trying to do. So I'm going to bring in the local authority into the ID field and also into the feature reference field down here. So this is the field that the visual will use to join our shapes in our custom boundary file to my Power BI data. So it's busy complaining that we haven't got the right fields added for a circle layer. So let's turn that circle layer off. Now I'm going to turn on this new higher performing mode to add a little bit more risk to the demo. So this is the bit that's in development and in testing, but there's nothing like a live demo to find the bugs. So I'm going to turn on the fact that we want a shape layer, and that shape layer is going to come from a file. We also have the ability to load in shapes from the Power BI data or your underlying database, but we're going to stick with the same scenario as we were doing in Azure Maps to start with. So we are going to pull in that file from an uploaded file rather than an external URL. So let's bring it in. So it's the same file, local authority districts. The visual is going to convert the coordinate system and display it on the map. So you'll see that we get all of those areas in England in blue, that it's matched back to our crime data, and then the areas that it hasn't matched in Scotland, Wales and Northern Ireland are in grey. And similarly, we can choose to not show those. And then it's just a question of applying conditional formatting to create a choropleth map based on the number of crimes. And I can change the background color to black, the outline color to black, and then we get our choropleth map. If I add in my slicer, we can zoom into London or head up to the northeast or northwest, and you'll see that the map zooms to those areas in question. I've just seen I know I'm not keeping up with the questions in the comments, I will come back and address them before we finish, but I've just seen that one pop up about projections. So what happens when you upload a shapefile is it will read the projection information within that shapefile, and it will convert the coordinates to longitude and latitude WGS 84 coordinates for you behind the scenes. So you don't need to do any of that yourself beforehand. The other thing it does, if you've used ShapeMap much, you'll know that you had to usually simplify those shapes to reduce the number of points in your polygons to make it performant on the map. It also does that for you behind the scenes. But if you do find it simplifying your shapes too much, you can tweak some of the parameters here to keep that level of detail if you want really detailed shapes. Right, so we've got our choropleth map for local authority districts in England, but what if I want to get into the detail and find out what's happening within them? Well, one of the things that we can do, which the other visuals can't, is we can still do drill down even on shapes. So I'm going to say I'm going to have 2 levels of drill down, and then I'm going to configure that second level. I'm going to upload the next layer of geography. This is a much bigger file with nearly 35,000 polygons in it, so it will take a moment just to process. And then it's just a question of me applying the same conditional formatting, because we can have different formatting applied at each level of the hierarchy if we want it. But I'm just going to apply the same for this very quickly. And then I'm just going to drag in those fields to create my hierarchy in the data. And then if we zoom into London, for example, I get the drill down controls here. And let's drill into Westminster and see within Westminster where those particular areas of crime are. Now, the interesting thing is, you'll remember that I said there were, well, actually, there's just over 35,000 of those much more granular shapes in England. But, of course, there's that 30,000 row limit for data in the Power BI visuals. But in IconMap Pro, we can choose to extend those 30,000 rows. So 60,000 should cover it. And then I can drill down into not just one area, but I can actually drill down and view that whole level of a hierarchy all at once. It does take a moment to process the first time because there are a lot of these shapes. And then you'll see that we can zoom all the way in, not just into Westminster, but the whole of the UK, the whole of England at least, all in one go, and get that choropleth map for the whole of England. Now, this is all very well, but the UK is a small country. I decided to have a go and see how this would work over here in Canada. So I downloaded the shapefile for Canada at various levels of geography, and even just the provinces and territories file was over 350 megabytes, at least at a good level of detail. And in order to make it a sensible size to upload into the Power BI file, I lose so much definition that it wasn't really achievable. And this has been a bit of a problem as well for doing things like viewing US zip code areas, for example, or some of the census areas in the US, or even France has a really detailed set of divisions. And again, it's a bigger country than the UK. So we need another solution for dealing with these larger amounts of complex geography, because we can't upload really large files into Power BI because, to be frank, it crashes. We're limited as to how much memory we're allowed to use in Power BI, and we don't want to be bloating our Power BI visuals files because every time we open that report, it's got to download all of that data to our users' computers, which impacts performance. So I'm going to bring in another Power BI desktop file. This is a big data set. I think I loaded in about 20 gigabytes worth of census data for Canada. And then I've got a geographic hierarchy as well for different levels in Canada. So the strategy today for dealing with this is, because we can't view the whole of Canada all in one go as one file, what we have to do is break it down into something called map tiles, where the advantage of the map tiles is it's the same technology as the background maps use. You're only viewing the detail for the zoom level that you're looking at. So if you're looking at the whole of Canada, it hasn't got every single individual little point that makes up that really jagged coastline. It's only got enough to be able to see that jagged coastline at the level that you're looking at. But when you zoom into the map and want to get, into the detail, it then only returns that smaller area that you're looking at, but those polygons contain a lot more points, so you don't lose any detail. But to be able to do this, today, you either need to have a GIS server sat in the middle for HiCoMap Pro to point at, and that could be ArcGIS. It could be Mapbox, who provide a tiling service, or it could be an open source solution like GeoServer. But it's still either an additional expense or administration overhead, making all of this work. So what I want to show now is what's coming in a couple of weeks. And this is something that will be built on to make it much easier over the coming months. But we've added some functionality for a new cloud native format called PM tiles. So that 450 megabyte shapefile is now a single 10 megabyte file, which I've just saved into Azure Blob Storage. So there's no server required for this, so you haven't got any compute costs, and it's only a really small 10 meg file sat in blob storage, so it's super cheap. I've got it in an anonymous, obviously can't say that, it's an anonymous blob store, but you could make it private and use SAS tokens to secure it if it's sensitive geography. So let's have a look how this works. So I'm going to go right into the deep end, and so I've got this whole geographic hierarchy here, going from provinces and territories down to census divisions, down to census subdivisions, and then down to the really detailed dissemination areas. So I'm going to start with the dissemination areas, if I can grab the right field. So let's pull that in there. And so it's the same set of fields as we used for the GeoJSON files. So I just need to drag it into the feature reference. And then in the map configuration, we don't want circles, but we want vector tiles. And we're going to use this new PM tiles format. And I want it to automatically zoom. And then I'm just going to cut and paste the URL to that file in my blob store into this box here. And then if the demo gods are with me, we'll head over to Canada. And we'll see that, well, we've got this amount of geography that's been matched with my Power BI data, and then the rest of Canada's in grey. Well, the reason the rest of Canada's in grey is there's a lot of these areas. There's more than 75,000 of them. But that's not an issue, because as we've seen, we can increase the number of rows. So let's bump it up to 180,000 rows. And then we get all of our dissemination areas mapped to the Power BI data. And then in exactly the same way as we did for our GeoJSON file, we can go in here and just configure normal Power BI conditional formatting. Just let that take effect. Oh, actually, what I do need to do is just add a quick slicer on here and allow us to pick what we're looking at. So let's have a look at average age of the population. And then that should update the formatting. Now, just before I get rid of the outlines, I just want to show you how this works. So we've got these huge areas up here with these really large, long coastlines. In fact, they're really complicated. If I just drill in here, you'll see the amount of detail that we've got in these shapes. But you can also see, as I'm drilling in and out on them, we're not losing any definition. We've still got all of these tiny little islands and still being represented on there. We're able to handle those huge areas, but if I head over back to Vancouver over here, my Canadian geography serves me well, we can also handle these really small block level areas within the cities. Thank you for doing the Googling there for the link to PM tiles. I'll be posting up a lot more information about this because I see this as a huge change in the way that we're able to do much more with really large complex geographies in Power BI. So let me show you what that looks like with a bit of a bigger area. So if we start off at province and territory level, and then I can either drill down. So we drill down into British Columbia, and then let's drill in here all the way down into Vancouver City, and we get to those really detailed shapes. You know, they're super small. They're just a few buildings big in some cases. But of course, as you've seen, we can go and view the whole of Canada at a time with that, infinite level of detail. So this is a big new feature that will be released later this month. While I'm in here, we've only got 10 minutes left, so I'm going to walk through some pre-built examples of other things that we can do with Icon Map. But I just want to quickly give you a bit of a preview of something else coming this month as well. So talk a bit about background mapping. So with the old Icon Map, we were reliant on people using Mapbox for their background maps. Whilst it did show OpenStreetMap tiles, they're not really intended for production use. So for production reports, you needed to go off and use a third-party set of background maps. Since the beginning in Icon Map Pro, we've provided our own range of styles, but those styles were limited, and a lot of people were still preferring to use the Mapbox layers. But we've added additional styles this month. So we've got this DataVis style, for example, which is much cleaner for overlaying demographic type data on top of. But we've also provided a much requested feature, and that's to be able to customize the language of the labels, at least where we've got those translations. So if I choose Hindi, for example, you'll see that London, Birmingham and Manchester, Liverpool have got Hindi equivalents of those names. But the really cool thing on this is that you can use Power BI conditional formatting to pass in the language of your user. So if you implemented translations on the rest of your report, you can now get the map to also show the language to match the rest of your report. Particularly useful in Canada, I know, where you've got both French and English equivalents of a lot of in a lot of your requirements. Other things coming in here is if you don't like the styles that come out of the box, or you've got, you want them to match your corporate style, then you can go in and customize these. So if I want to get rid of the labels, I can turn those off. If I don't want the roads and railway network, I can turn off the transportation layer. We can add on hill shading if I want to see, what the terrain looks like. If we're doing environmental type reporting, it's useful. Or if we just frankly don't like the colors at all, let's say, I don't know, we want blue water and we've got a corporate yellow scheme, then, without having to use a third-party provider and generate your own style, you can do some simple customization of the style to match the rest of your report. So opens up lots of possibilities. Right. In the interest of time, let's jump over to the Power BI service. And I just want to walk you through a few of the capabilities. So we've done polygons. Let's talk about lines. Lines, or at least a limited implementation of lines, were also added to Azure Maps as well, just before Christmas. But lines in IconMap Pro have a lot more capabilities. So this report has all of the different routes that every airline in the world fly. So we're currently looking at British Airways. I can just pick random airlines and it will show the routes that those different airlines fly. I guess we could choose Air Canada and we can see the routes, obviously, that Air Canada flies. So lines in IconMap Pro are specified from a source to a destination longitude and latitude, and we can conditionally format the color of each line. We can change its width. We can change the pattern of a line. We can change its transparency. We can put text on it. We can put text along it, and we can add direction arrows, and we can animate them as well. So there's a huge amount of conditional formatting that's supported on a line-by-line basis. Sticking with aviation, let's do this one. I find it really hard to type when I'm doing demos. I think this one should do. We can also add on to the map images, which is where IconMap originally got its name. So in my attic above me, I've got a transponder listening to all of the aircraft as they fly above my house. And that information is being fed in real time into Microsoft Fabric using the real-time intelligence workload. And then this report is using a direct query connection against that KQL database inside of Fabric and is being updated every 5 seconds. So you should hopefully, at least where I get the data through, see these planes moving around the map every few seconds. So we can put images on the map. You'll see we've got different images for the different types of plane. We can change the width and the height dynamically through conditional formatting. We can rotate the images around, so you'll see that all the planes are pointing in the direction of travel. And we've also added on some complex line strings here, so you can see where those planes have been traveled. We're looking at 10 minutes worth of history, but I can increase that to see every plane I've picked up in the last 30 minutes, for example. And I've also added some labels on here as well, so where I've got them, it's showing the flight numbers, so I can see that this is an EasyJet flight, for example. And I've been collecting this data now for some time. In fact, I think I've got a rolling 6-month window now set up in KQLDB. And in that 6-month window, you can see I've got 360 million rows of data now in this data set. So what I'm doing is I'm using KQL's geospatial processing functions to generate to generate these hexagons, but I'm not using it to generate the actual hexagons themselves. This is a indexing system created by the taxi company Uber to divide up the whole world into a grid of hexagons of different resolutions, so hexagons of different sizes at different levels. And KQL natively understands this H3 system, and it's just returning back the unique ID of each of those H3 hexagon cells and passing that to the visual. Now, IconMap Pro will also allow you to take longitudes and latitudes, and it will generate the appropriate hexagon where the longitude and latitude falls. But in this example, it means that I can aggregate up 360 million rows of data in KQL database and then return a few 100,000 IDs of hexagons to IconMap Pro, and then display, in this case, effectively the busiest areas of airspace as I've detected it with my transponder very easily on the map. So, I mean, you can see just how far out I can pick up these planes, in some cases all the way out to over France. Oops, dragging the map around. And I've also added a new feature in here as well, which is the ability to extrude these hexagons out from the map in 3D. So this will also come out in February's release. And it's not just the hexagons that you can bring out in 3D. You can also bring out any polygons that you've added to the map. The only thing you can't do in February, which will hopefully land in March, is the ability to tilt the map in the way that you can the current Azure Maps visual. But hopefully we'll be providing more and more 3D support as we go through 2025, because I know we've got lots of use cases in mining, for example, that want to be able to plot things in 3D, like pipelines or mine shafts, and actually go under the ground. So we're getting there at enabling all of those capabilities as well. Right, I've only got a couple of minutes. Let me bring up a couple more examples. So that's kind of aerospace. We'll stick with transportation just for a moment. So we'll have a quick look at buses, for example. So this map, when it comes up, there's a lot of data in this one again. So this is every single bus stop and bus route serviced by one of the operators in the northeast of England. And I can filter it and say, you know, show me this particular route. Or I can say, show me all of the bus routes that service, I don't know if it's part of the world, but Benton Asda, which is a supermarket. And then that will filter the map. The bus stop I've sliced, we'll use conditional formatting to highlight that one in red. And then all of the other bus routes are shown. And then we've got conditional tooltips on the bus stops, where I can bring up the timetable for that specific bus stop and see, you know, when I can next catch the bus to Wallsend Metro, apparently. We can do similar things with the railway network. I've got a Power BI model that covers all of the train operators in Europe. But it's very similar to the bus example. But it's not just transport networks. We can also represent infrastructure as well. So things like pipelines, or in this case, this is the water main network in the Canadian city of Victoria. So I'll use conditional formatting to show the different conditions of all the pipes, and then we could maybe look at the pipes that are serving residential properties under the jurisdiction of Victoria City. made of cast iron, over 100 years old, and then use things like report page tooltips to pop up additional information, maybe the inspection logs or further information about the wear and tear of those pipelines. And of course, I could use drill through to move over to another page of the report, and even use Power Apps to then put information back into the report through right back. So there's a huge amount of potential there. I'll just show a couple more. I appreciate I'm out of time, but there's just two more I want to show quickly. Let's do this one. I think most of the examples I've shown so far are only showing one type of object on the map, but I just wanted to make the point that we can show all the different types of object on the map. So here we've got demographic data, so deprivation data by different indices. So if we want to have a look at deprivation by crime, for example, I can choose that, and the color scheme of the map will update accordingly. And then I've also overlaid, in this case, it's doctors and GPs, but I could show where all of the dentists in England are, for example. So this is quite useful if you've got stores or items that you want to understand, all of the demographics around. Maybe choose hospitals. And then do this one. Last example. There's lots I'm missing, but I just want to show this one. So again, this is polygons, but unlike the other examples where I showed polygons where they've either come out of a uploaded file or an external source such as tiles, these polygons are being loaded out of our Power BI data model. So they're actually stored, in this case, in a SQL Server database. If I drill through to the detailed page, I can show this in a bit more detail. Zoom in a bit on this one. So anything in color on this map isn't part of the background map. It's actually coming out of my Power BI data set. So I've got every single house, tree, lamppost, park, school, train station, whatever it is in London inside of a SQL Server database, which means it's all bound to my Power BI data. So I can do things like use report page tooltips. Don't know where we are in London, but I can see that this is a school. I'm using conditional formatting to change the color based on the type of object. But also in this report, I've got 100 million rows, 30 years worth of house price data. So I can then do things like select an individual subset of houses on my map, and then the other visuals on the report will be filtered based on just those individual houses that I've selected to show the history and house prices on just those properties, which appear to be very expensive. But anyway, I've got loads of examples and loads of different industries and sectors. I could probably do another hour walking through different examples and building reports, but I'm out of time. So I'm going to stop there. If you'd like to see any more, or you've got particular use cases that you would like to talk about, please do reach out. You can find me on these details. You can, as you've seen, get OpenMap Pro from AppSource and have a play. You can have a play without needing a license. All the features are fully fledged. You just need to close the license pop-up down. And I do encourage you to check out the OpenMap Pro website because there's a lot of documentation and videos on there on how to use it. But there we go. That was a very quick run through of capabilities in Power BI for geospatial analysis.
Thank you so much, James. That was amazing, especially the last one. that was super cool. Being able to do it directly from a semantic model, drill into specific details, and being able to show the data right on the dashboard. That is really cool. So I worked on a project last year. It was a Click migration, so Click to Power BI, supply chain company, and they wanted to show on a map um, going from one location to the other location, and then use the traces to show by width, like how much they were shipping, the quantity of the units they were shipping. But they said we cannot use any like third party tools. It has to be Power BI. I was like, no, sorry, you can't do that. I'd be lucky if I can just use a simple map.
Yeah, I mean, certified visuals has always been an issue as well. So map visuals can't be certified because, well, map visuals that use background mapping can't be certified because one of the criteria for a certified visual is that it's not allowed to reach outside the Power BI infrastructure for external resources. But obviously, those background maps are so big they can't be held within the visual, so they have to come from an external source. So just by their nature, map visuals can't be certified. But we have a security white paper that details out, exactly what resources that we talk to externally. We don't send any data to anywhere external, so we don't even offer geocoding because we don't want any of that Power BI data leaving the Power BI estate. So it's not uncommon for Icon Map or Icon Map Pro to be the only custom visuals allowed in a Power BI tenant, um, just because there's no other way of doing it.
So we have a few questions here. So the first one is, um, so the question was, during my analysis, having errors saying too much value for cities, not displaying all the data. Is it something I can do to fix that error, or is it normal? I use field map and the other visuals. I guess the first point there is, I think you mentioned something about field map.
Yeah. Okay. Um, so yeah, I guess it comes down to that limit. So field maps limited, I think, to 3,500 rows of data. So you very quickly fill fill that up. Azure Maps, as I said, supports more, so you'll get 30,000 rows of data. And then with Icon Map Pro, you've seen that setting that I was changing in the demo where you can override that maximum row limit. And at the moment, I think we support 300,000 rows, but our aim is to try and push that up to 1 million if we can. So, yeah,
Is
if you've
that a
got.
limit on what you can do, or is it a Power BI limit? Like how many data points can you see?
Yeah, so the limit, there's no maximum limit in terms of number of rows, but there is a maximum limit as to how much memory we're allowed to consume. So it's a question, it's a little bit of a balance. So if you're doing things like those H3 cells, it's just 2 columns of data. So you can easily probably hit 1 million rows without worrying about hitting that limited memory. But if you want to bring in 1 million complex polygons, then you're going to hit it, in the low hundreds of thousands probably. So it's really hard for us to preempt that balance, which is why it's a configurable setting. It also impacts performance as well. I mean, all this data's got to come down from the Power BI service into your Power BI report, which isn't massively efficient. So it does have a performance impact when you start bringing hundreds of thousands of rows into a report.
Next question by Abdul. Can we add that .tab extension file like in Map Info Professional?
Yeah, no, not at the moment. So this is Icon Map Pro question, I guess. So at the moment we support Esri shape files that are zipped up into a single file, KML files, GeoJSON files, and TopoJSON files. Anything else you'll need to convert in a third-party tool. But there's lots of those available for free. Like mapshaper.org is my favorite. But there's also QGIS QGIS. That's a open source toolkit.
Is there one format that works the best or is optimal for Power BI?
So behind the scenes, everything's converted to GeoJSON, but there's pros and cons of each. As you shape files are quite nice because they're pre-zipped up and they've got that projection data in them. But shape files can only have one type of geography at a time. You can't have a single file with polygons and points and lines, say, in the same file. There'd have to be 3 separate layers. Whereas a GeoJSON file can have multiple types of shape in the same file. Behind the scenes, we zip everything up anyway in IconMap Pro, so it shouldn't make much difference.
Puneet has a question. Is there a way we can do lines on train paths, tracks in Power BI? Something exactly like what you showed. So Puneet, if you want to unmute, if you have any specific requirements, questions on that, please feel free to unmute yourself. I think you already.
I think your audio's struggling a little bit. I'm struggling to hear the question, but was it train tracks?
Yeah, train paths or train tracks.
Okay. Well, if I can just spend 1 minute, I can show I can show an example of that. Just bringing up a report, and then I'll show my screen quickly. Start showing my screen while Power BI is whirring away in the background trying to find the report I'm looking for. Found the report. Let me show my screen. So I've got quite a few examples of this, but this is the railway network for one particular train operator in the UK, South Western Railway. So I live on the Portsmouth line, so let's drill in and have a look at that line. So you can see you can drill in here. We've got some different things going on here. We've got labels now for each of the stations. We've got an alert happening here, so we can overlay the alert icons. And then on the individual stations themselves, they're all color coded with different KPIs. And that's actually based on passenger numbers. So if I mouse over this one here, we can see that this station's Whitley. It's managed by South Western Railway. It's their 114th most visited station with 172,000 passengers. And then that line chart is showing the passenger numbers over time. And where it dips down, that's the COVID period. So the fact that this is red is showing that the passenger numbers haven't recovered since COVID. And then as well as the station view, we can start to do different things with the track as well. So we can change its color, for example, based on different types of features. So if we just want to see, it's not a good example, but where all the tunnels are, for example, let's make it wider. There we go, the tunnels, or maybe the embankments and the bridges and the cuttings, that kind of thing. Or we can change the width based on the the maximum speed at different sections of the line. Those all back on again. So there's all sorts that we can do. We can bring on different additional reference data. So this is the rest of the railway network in the UK, and also who's responsible for different sections. So we can see the different network rail responsibility areas. So there's loads that we can do with railways. We've got quite a few national train operators as customers, so it's a really common use case for us.
So that's the end of the question. A couple of questions that I had. Since you have been doing this for a very long time, what's the coolest application you've seen so far that's built on IconMap?
So I think my favorite is still the original and first. So the original. So how IconMap came about is right at the beginning of Power BI, when custom visual, well, actually before custom visuals were a thing, I was invited by Microsoft to a meeting with a aircraft engine manufacturer. There aren't very many of them, so you can probably guess who it was. And they had this requirement that they wanted to be able to see where all of the planes were with their engines were in near real time, and also be able to see any alerts or incidents with aircraft either in flight or on the ground, so they understood where service engineers needed to be and all of that kind of thing. And they used it in this global operations center, centers around the world on these giant screens. So it got quite a bit of publicity at the time. Lots of senior people in Microsoft demoed it. We did the keynote for Microsoft Envision back when it was an in-person conference in Orlando. We had the CTO for that airline company. We had the demo with surface hubs everywhere. So I think that's probably my favorite use case, just because it was real time and it got a lot of visibility. But I've seen some amazing environmental use cases. People, we've got a customer who are I think they grow lettuces over vast amounts of the countryside, and they fly zones over all of the fields, detecting where they need to put additional nitrogen and other chemicals. And then they display all of that on those hexagon grids on the map. And then they use the lasso tool to identify particular areas of the field that need more fertilizer. And then that's then fed out into the crop dusters. So the actual output from Icon Map is actually feeding on a 50 centimeter or 50 or foot by foot area, driving how much chemicals are being put on these fields. So yeah, that's probably one of the coolest use cases I've seen of using drone telemetry. But yeah, there's so many different ways it's being used.
And then so Icon Map Pro, I'm guessing there is a, I guess does premium support more data points, or is that just the limit on the semantic model itself? Or do you get,
Yeah,
if you get more RAM, is it more responsive in that sense? Or?
So if you've got a more powerful machine with more memory, it's likely to perform a bit better, maybe. But that limit's imposed by the Power BI Visuals API. It's just a hard limit on how much data is allowed to be sent to the visual. To be fair, it's a sensible upper limit. I mean, it's a client-side application at the end of the day, and it's there's only so long people are prepared to wait between clicking on a visual and that data being sent and the report responding. So whilst it's on one hand frustrating that we can't send more data to it in the current Power BI architecture and infrastructure, it's a sensible limit.
And how do you think Fabric is changing how you are, I guess, working on projects now? So you mentioned KQL, right? So now you have that ability to have the data, host the data with real time, and then with Fabric in general. How do you think that has shifted just purely from Power BI to Fabric, at least with your vision?
Yeah, so the real-time intelligence workload and having KQL database inside of Fabric is fantastic, because KQL has native built-in geospatial processing functionality. So a lot of the things that we've been wanting to do inside of Fabric, we can now do. And yeah, I've been making good use of that. But there's also quite a lot else happening in Fabric. So Esri are releasing a custom workload, notebook based rather than visual based, for doing geospatial processing inside of notebooks. So Whilst Esri have got the ArcGIS visual, it's still really limited in what it can do. But I can see IconMap Pro being used to visualize the output of those new Esri geoprocessing workloads. We're planning on building a low-code geospatial processing engine inside of Fabric as well. So there will be more coming. Databricks are busy, whilst it's not Fabric, but Databricks are busy releasing more geospatial capability. Obviously, Fabric's now got good integration with Snowflake, and Snowflake has some basic but more than other bits of Fabric. It's got support for geography fields inside of Snowflake. And of course, we're seeing SQL Server coming to Fabric as well. And SQL Server has native support for geospatial processing too. I haven't played with it yet, but yeah, be interesting to see what we can do with all of those different workloads inside of Fabric, and hopefully we can be the presentation layer for it.
Yeah. We'd love to have you again when we get there. And one last question: since you have so much experience with building custom visual and how the process works on the back end, so when I work with customers, obviously the first rule we use is always use certified visuals, right?
Yeah.
Certified third-party visuals. But what does it exactly mean that a visual is certified? Is the data still within RBI? Like, what is that? What does that process involve? And are there still some risks involved with that?
So when a visual's certified, it means that Microsoft have done a code review on it. I don't know how thorough that is, but there's also a list of criteria that visual has to meet. So it can't use, I mean, well, we've already talked about the one where it can't talk to external resources, but it can't use commercial libraries either. So it's either code that you've written yourself or it's open source only. And then there's a list of specific features it has to support as well. So it has to be able to support all of the Power BI capabilities, like, drill through, drill down, all of those items. And there's also some specific internal functions that it requires to enable things like export to PDF and that kind of thing, which non-certified visuals don't have that requirement, so Microsoft don't turn that functionality on for them, which is frustrating for us because we've got that code in there. It would work if Microsoft, enabled the call from the front end. We could do export to PDF from maps natively and within the Power BI infrastructure, but we can't. But yeah, you should be able to trust certified visuals. The uncertified visuals aren't necessarily a risk, but they might be. So, I mean, what we offer our customers access to the source code so they can do a code review. We've got the security white paper, and then we've passed so many security reviews now. I'm pretty confident that we're good. Nobody's flagged anything up yet. And then once you do decide that you trust a non-certified visual, it doesn't mean that you have to open up your tenant carte blanche to non-certified visuals. You can use organizational visuals to create, specific overrides for the visuals that you decide are trustworthy and you want to incorporate.
Thank you so much, James. Really appreciate your time. Super insightful. The chat was pretty busy. Lots of reaction. So really appreciate it again for taking the time to be here with us. And we would love to have you back again. Useful.
Well, yeah, really grateful for having me. It's been fun.
Sure.
Great.
Thank you so much. So before we wrap up, I'm just going to share my screen again. So as I mentioned, February 20th, So just 3 weeks from now, our friend Fernando, he will be sharing his sessions are designing income statement in Power BI. So I'm looking forward to it. I'm not sure if the meetup link is already up or not, but I'll remind Parvinder if it is not, so you can go ahead and sign up for that one. But again, very much looking forward to it. And the recording, I'm going to stop the recording, but this recording will be up in a couple of days from now. So in case if you want to revisit it, see previous sessions, please take a look at that. So thanks again, everyone, and really appreciate you joining. And thanks to everyone who joined us today. Thank you.